Okay. Hi students, how are you, all of you? After a long gap, I have again come up with another video on stress and strain as I have promised. Last week I was down with viral fever, cold, cough, so I was not feeling well. For that reason, I could not upload any video. My regular classes were going on though. Okay, so now today I will start with the stress and strain. What I will solve, that I will solve, as you can see it in the board, that I will solve 6 problems which have appeared in the GATE civil engineering as well as the GATE mechanical engineering. So this is, as this course is meant for GATE, I hope that all of you are very much comfortable with the very basic definition. I will take a quick recap, and you go to the playlist, civil engineering GATE playlist, you go over there. So please see my videos on the theory part. Okay, even if you have forgot, you go through the theory part and then start with this video. But just to start with the video, I have written again some this thing, some formulae over here which are going to be used in this topic. So you can just have a look at it, and you can write it down. Just pause the video over here and then you write down all these formulae. So the first thing I have discussed over here is that what is stress. Stress is the stress, we denote it as sigma, that is equal to internal resistance divided by the cross sectional area. Always you remember, stress is the internal resistance offered by a body when an external load is applied. Okay, so we are denoting the internal resistance as R divided by A is the cross sectional area. Now as the internal resistance is equal to the force applied on the body because of the law of equilibrium, so we can write that R by A is equal to P by A, as R is equal to P. This is the basic thing, you know. Then what is strain? Strain is epsilon, the symbol is known as epsilon. So strain is known as the change in length by original length, right? So what is change in length? That whenever you are applying a force to a body, the body elongates. If it is a tensile force, then it will elongate. If it is a compression, then it will shorten, correct? So that is the change in length divided by the original length, that is delta L by L. What is the next formula? That is the elongation. What is the elongation or the change in length? Delta L is equal to PL by AE. So these all these formula should be at the tip of your finger. Okay, what is P? P is the applied force. What is L? L is the length of the bar. What is A? A is the cross sectional area, and what is E? E is the modulus of elasticity. Okay, then now here there are 2-3 formulae more which you have to be very alert. The next formula I have written about the elongation, that is the 4PL by pi E d1 d2. This is for a tapered circular bar. I will take up one problem. I will solve one problem based on this gate problem. So you will understand what is a tapered bar. Tapered bar means at one side the cross sectional area is more, and after that the other side the cross sectional area is less. So 4PL by pi E d1 d2. P is what? Applied force. L is what? The total length of the bar. E is the modulus of elasticity. D1, D2, they are the diameter at the both the ends. As the cross sectional area is not same. And there is another formula that is delta L is equal to WL by 2AE, where W, this is the formula for the elongation which is subjected to a self weight, due to self weight, sorry. So W is the self weight, L is the length, and A and E already I have explained. Now here this side I have written two very basic thing, already you know it, but it should be at the tip of your finger. First of all, what is MPa? MPa is Newton per millimeter square. And what is GPa? GPa is gigapascal, but the conversion of 1 GPa is equal to 10 cube MPa. So this is just in short whatever formula we are going to use over here, but please see the, go to my playlist and see the video on the theory part of the stress and strain. Definitely you see over there, I have discussed already about the theory questions which have appeared in the gate part. Okay, now I will start with problem. Total 6 problems I have taken up, so I will solve one by one. problem. So let us start with the problem number 1. See, problem number 1. Problem number 1, I think you can see it very comfortably. Yes. This is the problem number 1. This is one prismatic bar. What you understand by a prismatic bar? Prismatic bar means the cross-sectional area is same throughout the bar. So this is a prismatic bar. You can see the forces acting on the body. These points are denoted as P, Q, R, S. These all forces are in Newton. The cross-sectional area is in millimeter square. What you have to find? You have to find the stress in the part QR. QR. In this part you have to draw the cross-sectional, the stress in the part QR. So for this problem, how we will solve the problem? We take a cross-sectional area like this way, we divide it. Now we can draw either the cross-section of left-hand side or the right-hand side part. So what will be the cross-section? What will be the free body diagram? The free body diagram will go like this way. This is the section. This is the 35. This is 63. Are you getting it? This is the cross-sectional area, cross-section I have drawn. So this is the XX part. If I am drawing the left-hand side part, so 49 will not come. Okay, this part I have drawn. This is P, this is Q. Is it okay? So can you tell me that what will be the resistance developed over here? See, this is 63 over this side and this is 35 over this side. That means 63 minus 35, that is 28. So this is 28 this side more. So the resistance will be 28. Have you understood it? Please understand that, see, this side it is 35. If this side it is 28, then from the equilibrium this is perfect, because left hand side it is 63, right hand side it is 35. So what will be the net internal resistance? That will be the 28. 63 minus 35. Why minus? Because it is left, it is right. They should be opposite in sign, right? So this is the internal resistance, R equal to 28 Newton. Now what we have to find? Stress in the part QR. What is the formula? Stress, what is the formula? Just now I have explained you, internal resistance divided by the cross-sectional area. Okay, so what is the internal resistance by cross-sectional area? That is 28, and cross-sectional area it is given as 700 millimeter square. This is given. So 28 divided by 700. This. So what will be the answer? What will be the answer? Sorry, here the forces are given in kilonewton. Forces are given in kilonewton. So here it will be kilonewton into Newton, 10 cube Newton, correct? So the final answer is coming as 40 MPa. 40 MPa. 28 into 1000 divided by 700. Why 28 into 1000? Because the forces are given in kilonewton. So kilonewton to Newton, 10 cube, and what is the area? 700 millimeter square. This is given. So if you do it, then it will be 40 MPa. Please let me know in the comment box if there is any doubt, or if you have any doubt over there, or whether you have understood it. Please put it in your comment in the comment box. Now problem number 2. The same thing. This is another bar. Here it is 100. Here it is 50 Newton. Here it is 250. Here it is 200. And these are the length are given 500, 800, 400. And these lengths are all in millimeter. Now in this problem, modulus of elasticity is given as 200 GPa and cross-sectional area is 25 millimeter square. You have to find total elongation. So how we will solve this problem? So we know that the basic, what is the formula for the elongation? Just now I have covered. So delta L, or I have used just now, I have shown another symbol, another notation. So let us say delta L. Okay, so delta L is equal to PL by AE. We know that the elongation due to the applied force is like this way, but we have to find 1, 2, 3 in these three parts. So it will be summation of all the elongation, correct? Now this part, this part, this part, separately three parts we have to find, and then we have added, we have to add it up, right? So PL by AE. Now in this problem also you have to again draw the free body diagram and find out what is PL by AE. Now for this part, let us name it as same PQRS. Now for the part PQRS, if you draw the free body diagram, for the part P, this is 100. Here if we draw a cross section, so this will be 100. This is tensile in nature, right? Right, this is this part. For this part, this is 50. Then this will be R3. R3 will be 50. This is also tensile. Why tensile? Because this is pull along tension. So these two. Now the middle part. Again you draw one section just like the previous problem I have shown you over there. So how we will draw the last part? This is 100. This is 250. Now from here you have cut. So this is now, so this will be R2 will be 150, but this is compression. Have you understood? If you have understood the last problem, this is also, this part also you have understood. Is it okay? Is it okay? Right? So what will be sorry, what will be the total elongation? So what is P? P is over here in the first part, it is 100. What is L? Length is 500. For this part, what is the length? 500. And you keep A and E. Okay. So this part A is 25. E is 200 into 10 cube. This is what? For GPA to MPA. GPA to MPA. 1 GPA is equal to 10 cube MPA. Correct? This is for the first part. This will be positive. Why? Because this is tension. Now, for this part, third part, what it will be? Again, it will be plus as it is tensile. So, P. What is the L? Third part ka L kitna hai? 400. Correct? And it is the same thing. Correct? 25 into 200 into 10 cube. Now what will be this part, the middle part? Middle part के लिए कितना होगा? ये minus हो जाएगा. Why? Because this is compression. This is compression. Why it is compression? 150 like this way. See, this way it is 150. This way it is 250. Correct? So in this direction the internal resistance will be 150 because 100 plus 150 left में जाएगा तभी ये 250 balance होगा. Is it okay? Now ये जो arrow है, arrow का direction मतलब this is compression, push. So it will be taken as minus. Is it okay? So minus how much? 150. अभी middle part का length कितना है? 800 है. So 800. AE remains same. AE remains same. So do it and let me know in the comment section how much you are getting. How much you are getting. And while solving this problem, this the denominator na you take outside. Do not do everything separately. Are you getting it? First take this denominator out because this is common for all three fractions and just calculate this. So this question I am not putting it in the comment box. Putting the answer over here. You please put your answer in the comment box and I will let you know what will be the correct answer. Okay. Okay, now let us go to the next problem, that is problem number 3. Problem number 3, can you see? Yes. Now what is problem number 3? Problem number 3, again there is one prismatic bar given. There is one prismatic bar given, correct? Here there is one P, here there is one P. Two tensile force is there. This is L by 2, L by 2, half length, half length. Now, for the half length, the modulus of elasticity is E1. For this part, the modulus of elasticity is E2. So, the question is, what will be the normal stress at this section, this SS section? What will be the normal stress at this SS section? This is very, very clever question and very good conceptual question. What will be? What will be this normal stress? The area of the cross section is given as A. A is the area of the cross section. A is the area of the cross section. So the normal stress over here will be P by A only, because as stress does not depend on E, modulus of elasticity. Is it okay? Have you understood? Okay. This is a very good question. Now let us come to the question number 4. Question number 4, please note down the diagram over here. Please note down the diagram over here. Okay. Now this is a given that this bar is given of square cross-sectional area. This is 100 millimeter square for this part, and this is 50 millimeter square. Now maximum stress this bar can withstand is 25 MPa. We have to find the stress in the part AB and BC. AB means AB and BC, ये part. Correct? ये दोनों part पे stress निकालना है. This is also another very good problem. Okay. So again you have to draw the free body diagram. AB part or BC part. देखो. See, I am drawing the diagram over here. We are starting with the BC part. BC part जैसे ये नीचे है ना, तो हम लोग इधर से diagram draw करना चालू करेंगे. Okay? तो इधर से अगर डायग्राम ड्रॉ करना चालू करेंगे, दिस इज 50, करेक्ट. आई एम ड्रॉइंग द BC पार्ट फर्स्ट, क्योंकि ये नीचे है, नीचे ही ड्रॉ करेंगे, ऊपर जगह खाली रखा है, इधर AB पार्ट का डायग्राम ड्रॉ करेंगे, राइट. तो BC पार्ट के लिए क्या होगा, देखो ये 50 है, ये गिवन है 50, ठीक है. तो इधर कितना होगा रिएक्शन, रिएक्शन विल बी 50 ओनली. इज इट ओके? नाउ इफ वी ड्रॉ AB पार्ट, AB पार्ट के लिए कितना होगा, दिस इज A एंड दिस इज B. देखो तो दिस पार्ट के लिए 100 एंड ओवर हियर दिस इज 50. सो हाउ मच इट इज एक्टिंग ओवर हियर, 250. टोटल इट इज 250. सो व्हाट विल बी द रिएक्शन फोर्स, द रिएक्शन फोर्स विल ऑल्सो बी 250. Reaction force will also be 250. Now, what will be the stress in the part AB? So, sigma AB is equal to 250 by what is cross-sectional area? 100. That is 2.5 MPa. What will be sigma BC? Sigma BC will be 50 by, इसका cross-sectional area कितना है? 50. That is 1 MPa. So the answer is 2.5 and 1, because this is 50 and this cross sectional area is 50. Is it okay? Is it okay? Now question number 5. Question number 5, can you see it over there? Now I have come to the next part, that is question number 5. What is question number 5? Again there is one bar given of different cross sectional area of equal length, L. This part cross sectional area is A, this part is 2A, this part again is A. Is the problem clear? और ये P क्या है? This is another external force. We have to find the expression for the total elongation. Is the problem clear? We have to find the expression for the total elongation. Tell me how we will go for it. Okay. So total elongation will be delta L is equal to summation of PL by AE. We know na. So for the first part, what it will be? PL by AE, ये पार्ट के लिए. सेकेंड पार्ट के लिए क्या हो जाएगा? PL by 2AE प्लस थर्ड पार्ट के लिए PL by AE. Why it has come P over everywhere? Because as I have taught you in the first problem, question number 1 में जैसे मैंने सिखाया था, if you draw the free section wise, if you draw the free body diagram, you will see for every section it is coming P. So the force for each part will be P. Only the area of cross section changes. Okay, so for this problem the answer is 2.5 PL by AE. This is the answer. Now I have come to the last problem of this session. So as you have seen that this is a tapered bar. This part is tapered bar. Tapered bar का मतलब अभी समझ में आया डायग्राम देख के कि एक ये देखो इधर एक डायमीटर है, इधर एक डायमीटर है, करेक्ट. And this is a prismatic bar. मतलब at every cross section the area of the cross section is same. Okay, this is 2 meter, this is 1 meter. ये इधर एक फोर्स लग रहा है 30 पाई किलो न्यूटन. यू रेड इट राइट. दिस इज 30 पाई किलो न्यूटन. इज इट ओके? इज इट मोर क्लियर? या 30 पाई किलो न्यूटन. देखो इधर का डायमीटर, ये फाई इसका सिंबल मालूम है ना, फाई मतलब डायमीटर, करेक्ट. और अगर कहीं पे भी यूनिट लिखा हुआ नहीं रहता है सो इट इज ऑटोमेटिकली इट इज मिलीमीटर. ओके, सो 510 मीन्स डायमीटर ऑफ दिस. फर्स्ट ऑफ ऑल दिस इज अ सर्कुलर क्रॉस सेक्शन. फिर इसका डायमीटर है 10, फाई मतलब डायमीटर, एंड इट इज ऑफ 10 मिलीमीटर, एंड दिस इज फाई इक्वल टू 20 मिलीमीटर. नाउ फॉर दिस प्रॉब्लम ई इज गिवन एंड वी हैव टू फाइंड इलोंगेशन एट ए पॉइंट पे इलोंगेशन कितना होगा. ओके, दिस इज द लास्ट प्रॉब्लम ऑफ टूडेज सेशन. तो देखो वापस, व्हाट विल बी इलोंगेशन. इलोंगेशन हाउ वी कैन फाइंड इट आउट. देखो फॉर दिस पार्ट इट विल बी हाउ मच. This is the force P. What is length? Length is 1.5 meter. बट देखो ऑप्शंस में ना हमेशा ध्यान रखो वो MPa में पूछते हैं या न्यूटन पर मिलीमीटर स्क्वायर में पूछते हैं. दिस इज 1.5 मीटर. तो सबसे पहले इसको कन्वर्ट करो. 1.5 इंटू 10 क्यूब. सो दिस इज P इंटू L. इसका एरिया कितना होगा? पाई बाई 4 डी स्क्वायर. This is area. Is it clear? What will be E? E is 2 into 10 raised to 5. ये MPa में ही दिया हुआ है. Then we don't need to convert. So this part we can tell it as delta L1. मतलब ये part के लिए. और we can tell it as delta L AB. AB के लिए, ठीक है. अभी हम लोग delta L BC के लिए कितना होगा. Now just now before the start of our lecture I have told you that for a tapered circular bar it is 4 PL by pi E d1 d2. So 4, what will be P? P will be the same. Sorry, this is again in kilonewton. So this part also we have to convert. ये 10 क्यूब किसके लिए आएगा? ये किलो न्यूटन से वापस न्यूटन में. हाँ, तो ये गड़बड़ हो गया, तो इधर अभी मैं कर देती हूँ, ठीक है. P. What will be the length? Length will be 2000 मिलीमीटर. मीटर से मिलीमीटर में कन्वर्ट किया, राइट. नाउ व्हाट विल बी ए. ये पार्ट का देखो नहीं, 4PL डिवाइडेड बाई पाई E. इधर एरिया नहीं है, इधर क्या है? d1 d2. सी द फॉर्मूला. सो व्हाट इज d1? ये पार्ट का डायमीटर कितना है? d1 10. ये पार्ट का डायमीटर कितना है? 20. Have you understood or not? Please let me know in the comment box. This is d1 d2. This is pi E. This is 4PL. This is what? PL by A. This is E. I hope you have understood it. Okay. तो इसको प्लीज सॉल्व करो और इसका आंसर बताओ कि कितना आ रहे हैं. सो व्हाट विल बी टोटल लेंथ विल बी दिस प्लस दिस. सो द आंसर इज कमिंग. आई विल लेट यू नो द आंसर. राइट डाउन द आंसर ओवर हियर. 15 millimeter. 15 millimeter. So that's all for today. So please let me know in the comment box. How you like my video, and on which topic you want to see more videos on it. I also take personal tuition. If you want any personalized tuition for GATE coaching for civil, architecture, mechanical few subjects, you can contact me prof.megadatta@gmail.com. I take regular tuitions for that, or for semester study you can also contact me. And please remember that these take lot of effort. So if you like my videos, please press the like button and also subscribe my channel, so whenever there is one new video you will get the notification. Okay, so that's all for now. I will come up with the next topic on structures or on strength of material in my next video. So see you in few days. Okay, bye.